Find the inverse of the following functions. We've got f of x is equal to 4 minus 3x cubed, x belonging to R, and f of x is x minus 2 over x plus 3, x belongs to R. But notice x cannot be equal to 3 in that function. And f of x is 3 over x minus 5, x belonging to R, where x is not equal to 0. So what we're trying to find here, if I take a number, cube it, multiply it by 3, and then subtract that from 4, is then the answer to that, what I want to know is, can I get back to my value of x? This is called finding the inverse of the function. But you need to remember that only one-to-one functions have an inverse. If you have a many-to-one function, the domain must be restricted so that the function is one-to-one. For example, if f of x is equal to x squared for x greater than or equal to 0, then the inverse function will be the square root of x. If you have f of x is equal to x squared for x less than 0, then that will have an inverse function. F to the minus 1 of x is equal to minus the square root of x. So if you combine both functions, then you have a many-to-one function. But separating like that will make them one-to-one, and therefore you can find the inverse. Okay, so if you've got f of x is equal to 4 minus 3x cubed, x belongs to a set of real numbers. If you let y be equal to 4 minus 3x cubed, and then what you do is you try to make x the subject. So just applying the normal rules of algebra, if we add 3x cubed and minus y to both sides, so that will have the effect of making this side 3x cubed, and then this side will become 4 minus y, so it's like saying taking that there and that there. And then dividing both sides by 3, we're going to have that x cubed is equal to 4 minus y over 3. And then to find x, we'd have to take the cube root. So the cube root of 4 minus y over 3. But here you've sort of got a function in y. So what you do, the last bit, is rewrite the inverse in terms of x. Now the symbol for inverse is f to the minus 1 of x. So it's the cube root of 4 minus x. So you replace the y with an x over 3 and then state its domain. So this domain will be x belonging to the set of real numbers. You can put every value in. Right, second function is f of x is x minus 2 over x plus 3. X belongs to a set of real numbers, but x cannot be equal to minus 3. This is called a bilinear function. So same process, let y be equal to x minus 2 over x plus 3. Multiply both sides by x plus 3. So you get y times x plus 3 is equal to x minus 2. Expand the bracket, so you're going to get xy plus 3y is equal to x minus 2. Now you're going to have the subject here appearing twice. So when you get that, the technique is to put the subject on the same side of the equation. So collecting all terms with x on one side. So I'm going to take away x. So I'm going to have xy plus 3y minus x is equal to minus 2. Then subtract 3y. So we're going to have xy minus x is equal to minus 3y minus 2. Now there's a common factor here of x, so that makes it a single value. So factorize the left-hand side. So you're going to have x times y minus 1 is equal to minus 3y minus 2. And then divide by y minus 1 on both sides. You're going to have that x is equal to minus 3y minus 2 over y minus 1. Now you could rewrite this, changing all the y's to x, but we can tidy this up a little bit. Here's a little trick. Factorize out the minus sign, so it becomes 3y plus 2, and then take the minus sign to the denominator, so it becomes minus brackets y minus 1. So that becomes 3y plus 2, and then if you take that in, you're going to get minus y plus 1, which you can write as 1 minus y. Now rewrite it in terms of x, so it's f to the minus 1 is equal to 2x plus 2 over 1 minus x. But notice that x cannot be equal to 1, otherwise you're dividing by 0. So you have to state the domain. The final one, we've got f of x is 3 over x minus 5. X belongs to a set of real numbers, x not equal to 0. Obviously you can't put 0 into that function. So let y be equal to 3 over x minus 5. Multiply both sides by x, so you're going to have xy is equal to 3 minus 5x. That gets rid of the fraction. Again, collect the terms in x on one side. So we're going to have, add 5x, so we're going to have xy plus 5x is equal to 3. Factorize out the left-hand side, so same technique as the previous example, so x brackets y minus plus 5 is equal to 3, and then you're going to have that, dividing both sides by y plus 5, you're going to have that x is equal to 3 over y plus 5. Rewrite in terms of x, so f to the minus 1 of x is going to be 3 over x plus 5, obviously this time x belongs to a set of real numbers, but x cannot be equal to minus 5, otherwise you're dividing by 0. So this has been a video to show you how to find the inverse of a function. Remember, you can only find the inverse of a one-to-one function. For many-to-one, you must restrict the domain. I hope you've understood, and I thank you very much for watching.